Hello, and thank you for attending this webinar, Never Overstock Again, Optimized Inventory with Azure Machine Learning. My name is Lucas Fyoke, and I'll be presenting today. I'm a senior consultant with Kaizen Technologies in the Advanced Analytics Group. Our agenda for this webinar will be the following. We'll start by looking at common business problems we have seen with companies who are getting started with machine learning. Next, we'll take a look at building a foundation with DevOps and how that applies to machine learning. Then with that, we'll move into a full life cycle of a machine learning project. We will review how to implement some best practices and processes for a ML project. And finally, we'll see a demo that is end-to-end for a machine learning operations solution. We will also be answering questions during this webinar, so feel free to type them in chat and we will respond accordingly. If something requires a little additional time, we can always follow up with you either by phone or email. So with that, let's begin. Often, we get asked about machine learning and how to start or what services we offer. While each company has specific use cases, machine learning projects should be based around a single question, and that is, what do you want to predict? Some of these questions might be, what is sales going to be in the following quarter or maybe the following month? Which customers should we select for the next marketing campaign? How can we determine what demand will be for next month, so that we can order ahead of time? Or maybe once we have built a model, how can it be used in an application? Or how can I access it on a mobile device? With machine learning, there's usually a data curation process that is required. Sometimes this data curation runs long and budgets go unchecked. But we'll see in this webinar how to monitor spending during all phases of this life cycle. We tend to look for processes that can be automated to help reduce costs even further. Finally, what happens after a project gets deployed and Kaizen leaves the project? Is that something that we're supposed to maintain or correct if it breaks, or do we call someone like Kaizen? We'll take a look at how we can manage some of these common failures or corrections automatically. While there are many more challenges, these are the ones that we typically come across. Next, let's see business problems that arise when working with machine learning projects. So years ago, Google put together this slide here showing the machine learning code at the center of this large operational engine that is often performed by multiple people, multiple teams of people, and typically done manually. So a lot of checking error logs or making sure that processes are running smoothly. But as you see on this slide, we have things like data collection, data verification, model analysis, serving infrastructure, and there's plenty more here that are all required. But with some of the processes and tools we will cover in this webinar, we will see how these areas can be covered and automated. To lay the foundation, we need to review what DevOps is and how it can be applied to machine learning. There are many different definitions when asked what is DevOps. The definitions listed here are lifted from various sources and organizations. They mention improving teamwork by increased communication and automating as many processes as possible. DevOps is not considered a piece of software or a hardware appliance that you can install and set up. It's really a culture shift in the way teams and departments work together, and as a result, a better product is delivered faster and more reliably. In the graphic below, we see the overlap having two continuous methods of integration and feedback. These are essential for when the developer team on the left-hand side receives the feedback to correct or build new features, and then the operations team can take what's packaged, the software that's packaged, and easily deploy it and monitor it for future feedback. Let us look more in detail on what the life cycle is for DevOps culture. First, we have to have a plan and an idea of what we want to achieve. Next, we start with that plan and begin development to create a foundational level. With that, we add features to that foundation, and as new things get added, they're verified and tested in like a testing environment or a quality assurance environment. And if any issues are discovered or don't meet requirements or user stories, those are sent back and the corrections are made until they're approved. Then the whole set of features are packaged together and handed off to the operational team. That way they can release it into a production environment. And similar to how the testing or QA environments are set up, the production environment will need to be set up and configured so that the specifications match. The product is then, or could be a website. This could be a mobile app. Could be a report. A Power BI report. That product is utilized in day-to-day activity as it was planned and monitored for any issues, any slowness, any type of maybe failures to communicate with different services, or there may need to be new features requested, or some other type of insightful metric that can be gathered. That feedback is then looped back in and sent to the drawing board, where this whole life cycle continues to constantly be improving that final product. Now let's switch over and look at ML Ops and its life cycle. We begin the same way as DevOps by starting with a plan. The goal of machine learning is to create a model that will predict the outcome based on specific inputs. In the next slide, we'll zoom in to see more of the details on a machine learning lifecycle, but for now we can just think of it as being created. The two additional things from the DevOps lifecycle is data and model. When developing a website, the tools are used like Visual Studio or other IDEs. Those tools are used to build the front end web pages, or maybe the back end services, or the mobile app interactions. It's a little different with a machine learning project where data is required and a model is produced. So the tools that are utilized are you can think of them well, they're more like the people involved. So subject matter experts, as well as maybe people who are in the field, or who are working with this as part of their day-to-day job. They are able to explain how the data is collected, or how it gets processed, or all of the knowledge around what this data signifying to include into a machine learning model. So that model gets selected, and there's a number to choose from, all based on the type of prediction that you're wanting to do. And it gets applied to the data and is then trained, and based on the accuracy of the results of that training, it's either considered useful, or we may need to go back and start this again. So it's an iterative process. This is the training process of the machine learning lifecycle. But once it meets the accuracy requirements and it's verified with test data, so data it is not trained on, but a different set of data that it can be used to test predictions. So once all of that has been verified, we can package it up and send it to the operational team. Similar to before, our production environment needs to be configured to match our testing and QA environments. Then, similar to how the website was monitored by responsiveness or communication, there's specific metrics with a machine learning model that are quite different from website or other applications, but it can still be captured and collected and brought back into the planning phase. The machine learning lifecycle is defined by the following iterative process. We have a plan of what will be predicted, and we have data associated with it. We train that model to predict the most statistically accurate value. This is then packaged up in a modular format to either be hosted or embedded within other applications. Next, it's validated by using tests and to check for things like functionality, responsiveness, as well as compliance with regulations, or even biased. And these considerations are defined during the planning phase. Next, once it's packaged, it's deployed and operationalized. So this is where day-to-day activity would be sending input to the model, receiving a prediction, and capturing any of those metrics, and then monitored to signal when a model may need to be retrained or deprecated out of service. And so it finalizes that whole feedback loop to have this life cycle continue. Now we have covered the foundation of what DevOps is and how it gets applied to machine learning. Microsoft has developed or designed this maturity model for MLOps. It's a 5-tier model, and listed here, um, we have the link to the documentation below. Basically, this is completing the steps manually as being the like no ML ops whatsoever. The next step is, you have some of the automation, building out the models or building out tests. Those are kind of automated, and that's DevOps, but no ML ops. The next step is you have building models or tests. That's automated. Plus, you have all the previous listed features, and you're able to track your model and collect those metrics. Then the next step is you have the previously listed features, but you also have deployment automated. So you're following like A/B testing or blue-green deployments or canary releases, and all of that is automated, and metrics are captured in order to provide feedback for the iterative process. And finally, at the top of the maturity model, we have full MLOps with all of the operations and processes automated. Now, this is a large undertaking as a company, but you do have the option to start small and grow as new features or models or processes are discovered. In order to begin an MLOps project and successfully implement it, there are 3 main things that we see as needing to be defined and followed throughout the project. People are the most important. These are the stakeholders, the folks who are day-to-day operators, the ones who are subject matter experts, as well as those who have the final say in decision making. There needs to be people involved so that we can help define questions, to do some investigative work in order to understand data, and then be able to define those questions and be able to predict an outcome. Next is the process. The process has to be documented, understood by all the people involved, and agreed upon. We want to have everyone kind of on the same page, and then this will be implemented in order to meet the demands or the requirements based on what the stakeholders, what they define as being meeting the company's needs, and what's technically or financially possible. Along with the process, we usually have checkpoints that are defined, as well as key metrics, so that everyone involved can understand what progress is being made by just seeing a few values. And of course, as mentioned a moment ago, the technical aspect of which platform to utilize will also be determined and agreed upon, and then this leads us to selecting the right tool chains or the right services, or maybe needing to purchase the correct services in a cloud environment. All of that needs to be decided upon and agreed upon before moving forward with the project. And then this leads us to a process that Microsoft has fine-tuned internally and then shared with us. Uh, this is called the team data science process, and it's a agile, iterative data science methodology to deliver predictive analytics solutions and intelligent applications effectively. It includes best practices and structures from Microsoft and other industry leaders to help drive towards a successful implementation of data science initiatives. The goal is to help companies fully realize the benefits of their analytics programs. This methodology, at a high level, is similar to the cross-industry standard process for data mining, or CRISP-DM, as well as the knowledge discovery in databases, or KDD. Both of these are the leading methodologies that have been used by data miners in the past. Next, let's take a brief overview of the team data science process. The goals of business understanding are to specify the key variables that are to serve as the model targets. We need to identify related metrics to determine the success of our project. Then we identify relevant data sources that the business has access to or needs to obtain. The data acquisition and understanding is that next step. Here is where we clean and create high quality data sets and gather them together so that all data relates back to those target variables. A solution pipeline is created to refresh the data regularly. Modeling will determine the optimal data features for the ML model. Then we create a model that predicts the target most accurately, creating a model that is suitable for production environments. Development of the model to production along with the data pipeline for final acceptance. Customer acceptance of that confirms that the pipeline, the model, and deployment satisfies the customer's objectives. Outcomes of a machine learning operations project is that the target objective is met and provides value to the business. The culture change will hopefully improve communication or at least make teams aware of this team data science process. The old problem of "it worked on my machine" is really no longer valid, as all environments for training, development should all be identical and reproducible. This provides higher uptime, meaning for faster and better quality results. All aspects of the process are managed, automated, alerted, so that more effort can be used to improve business functions as opposed to maintaining the model. For the demo, we will utilize a data set from Kaggle for store item demand forecasting. A link to the challenge will be listed below. We will also have a quick tour of the Azure ML Workspace and Azure DevOps for those who have not seen it. First, within Azure Machine Learning, our workspace has three main sections: Author, Assets, and Manage. First, our data stores, where we would define connections to our storage accounts. We then register a dataset against the data source. This way, we have a versioned, repeatable dataset for comparison. Then we need resources to run compute against our data. We have compute instances, which gives us access to pre-configured virtual machines that have different tools installed, such as Jupyter Lab, Jupyter, VS Code, RStudio, or a Bash terminal. Compute clusters are for small to large scale training. Each cluster can auto-scale and release nodes when demand increases and decreases. Inference clusters house the deployed model for scoring new data. In addition to these three, we can also attach custom computes if required. Azure ML has a built-in user interface for notebook authoring that's very similar to Jupyter Notebooks. Notebooks allow for saving and sharing output and having publishing quality layouts with text, code, images, and widgets all on one page. The Designer is a low to no code environment for drag and drop machine learning. Access to our datasets, transformations, feature selection, training, scoring, and evaluation, along with 19 ML algorithms. Automated ML is a great way to get started by allowing Azure to test multiple models and provide you with the best model to select. In this example, we see the profit model was considered the best model to utilize. Under the model section, we can see the algorithm, metrics associated with the AutoML run, and the duration of each run. Experiments keep record of the different trial runs for training models, running scripts, or automated ML. Models can be registered and versioned. This helps keep track of the results from experiments, or you may upload your own model here. Pipelines are utilized to create a repeatable process to train, score, and evaluate a model. In this example, we have the Designer and a real-time interface web service. Once we have a model that's ready for QA, we create an endpoint to serve to other applications. In this example, we see Azure Container Instances and Azure Kubernetes Services as endpoints. There are pipeline endpoints available for testing as well. Over in Azure DevOps, we can link our Azure ML workspace to a project. In here, we can source control any code that is developed, as well as YAML files that define our resources. For example, we have a train.py file that uses XGBoost to predict our sales for a given store. This file is then utilized in train and deploy YAML that defines our Azure ML workspace and tasks to train and deploy the output from our train.py. These are then executed as part of a continuous integration and continuous delivery pipeline using Azure pipelines. We have our train and deploy YAML file showcasing the different steps for this job. First, it will install the Azure Machine Learning command line interface on an Ubuntu OS, attach our workspace to the image, attach our cluster, and train our model on the compute to then register that model within Azure ML. Finally, the model, the code, as well as the image is packaged up and deployed to Azure container instances for QA and testing. Another pipeline is then developed and manually triggered to copy over this same image to an Azure Kubernetes service. This deployment model is then assigned a monitoring task to collect and detect data drift. This is done during the development of a data set where we can create a data set monitor, select our target data set, select a baseline, give it a name, select our features, select our compute target, as well as our frequency and an email address for any deviations. The monitoring data set can then be viewed inside of Azure Machine Learning to see what the drift magnitude is, as well as the different drift runs. We can also see the magnitude trend over time as we collect that data. Then, over in Azure Application Insights, we can view any of those custom metrics and set up a rule to alert us if any of those deviate from our trend. And if those conditions are met, we can have it perform actions like retraining our model. So let's take a step back and see what this looks like at a higher level. Number one is where we collect the data and clean it up and have unit tests such as minimum, maximum values, or negative values, or data that does not fit with the rest of the data set. We can then have a one-time run or utilize code such as Terraform or define YAML files in Azure DevOps to set up our workspace, compute, and pipeline. Number 2 is our retraining pipeline, where we can take that data and train a model and register it against our model management. Number 4 is where we can take that registered model and deploy it to a QA or test environment and have application insights collect the different metrics associated with our model. Then we can have a manual deployment to Azure Kubernetes service, where we can have a production environment that connects to other applications. Number 6 is where we can have those scoring services available for other application integrations or microservices. Finally, number 7 was our dataset monitoring that allows us to check for data drift and trigger a retraining pipeline with the new data so that it gets back in that trend. As we have seen, the ML code can be built with the associated services and features by utilizing build and release pipelines. The process is iterative in nature, and Kaizen offers services to meet the needs of each area. Following the ML lifecycle, Kaizen can meet with you to formulate plans with stakeholders and subject matter experts to define a question to predict by utilizing our project management team. We then have data engineers and developers that can create code required for training and developing models. Our data modelers and architects can help review your data and build out custom Azure ML data stores and data sets for versioning that data. ML engineers and data scientists can assist in model selecting, feature engineering, as well as reviewing any custom models. Our team members can work with you to verify the accuracy of the models and fine-tune the results to get the most out of your data. We have DevOps engineers and architects who specialize in Docker, Azure Container Instances, and Kubernetes to help package, deploy, and release models for testing and production environments. And these environments, of course, can be configured with cost and performance in mind. Once deployed, Kaizen can take a hands-off or a hands-on approach with customized support to help assisting with monitoring or troubleshooting or any other day-to-day operations. Azure Machine Learning and Azure in general offer many services and solutions to meet the ever-changing business landscape. If you want to learn more, talk with one of our account executives or feel free to contact myself directly with any questions. This will end the webinar for today, and Kaizen thanks you for attending, and we look forward to hearing about your next business project.